In this video, we're going to discuss the basics of using an array. Zero indexing is the most perplexing part about using arrays until you become comfortable with it. Because the array is a single variable name, technically it's a reference type, we must have some way of distinguishing each array element one from another. My analogy in the introductory section was to think of a book with page numbers. It's all one book, but each page has its own unique number. Likewise, the elements of an array have their own page number. Actually, it's an index value, but unlike a book, it starts at 0, not at 1. We think often of elements in terms of first element, second element, all the way up to last element. We can still do that, but those are what are called ordinals. First, second, third. Cardinals are the actual indexes, 0, 1, 2. So there's always that off by one tension that one may feel. One way to remember this is that the index describes the number of elements to skip in order to get to the element we desire. The very first element, which is stored at index 0, we would skip over no elements to get to it. Hence, its index is 0. Technically, this is true. The way array values are accessed is based on a computation of how many bytes to skip over to get to the element. So this is a technically true understanding. If it's helpful, use it. If not, ignore it. An array can hold multiple elements. I say here in the slide holds multiple values. Technically, the array doesn't. It has multiple elements. Each element has a value. Point is, we access it as if it has values in it. But because it has multiple values, it cannot be a primitive data type. It has to be a reference data type that uses that two-step approach. The reference variable that points to or refers to a memory location where the actual data is. And that data is the elements. So we have to use the new keyword to create that memory space. The reference variable is declared as base type with the brackets. Base type being the type of the element. So if we wanted to hold integers, we would say int array. We read the brackets as array. And then we give it a name, such as scores. The base type can be a primitive or reference type, so we can have arrays of arrays. And when we cover two-dimensional arrays, that's exactly what we will find. Because an array reference variable needs to have some memory associated with it, we have to use the new keyword to create that memory. As we see an example here, new int 5. Create enough space for 5 integer elements. The index range will be 0 to 4. The previous slide showed int array scores as a declaration of the variable, and this slide shows the initialization of that reference variable with the memory. This can be done and combined in one step. Int scores assign new int 5. It saves some time and coding effort, and it's generally preferred if you can. Initializing the element values of the array is essential for any element value other than the 0 for that data type. I would recommend you always explicitly initialize each element, even if the value is 0. For values other than 0, we could do the initialization by hand. For example, scores index 0, assign -1. That's tedious, however. Better is to use a loop that indexes from 0 to the maximum index. The maximum index is always the number of elements -1. Our array has 5 elements, so the maximum index must be no greater than 4. This loop goes from 0 to 4. It says scores sub I assign -1. That's far easier than putting in the index values by hand, particularly if the number of elements in the array has to be changed later, say from 5 to 10. You would have to change only the declaration and definition of the array. This loop would continue to work. The hard-coded index values would fail. While it is tempting to hard code the index values, because it's easy at first. Don't do that. Almost never hard code the index values. Use a loop or some variable to compute that index. Those index values are integers in range 0 to number of elements minus 1. Use some sort of computation to determine that index value. That's the key to using arrays effectively. It may take a conceptual leap to figure out how to transform the problem into the computation of those index values, but that's important to learn. Another way to initialize an array is to hard code the specific values, but the syntax is a little different. Notice here we say int array scores assign, and in braces we say -1 for 5 values. This means we will create an array of 5 elements, each initialized to -1. I did not specify how many elements directly. I let the compiler figure that out. If we do this, we may have the lingering question, well, how many elements did I actually create? The program may need to know. If we put the array name .length, we always get back the number of elements. I said the number of elements, not the maximum index. Scores.length is the number of elements, 5 in this case. Scores.length minus 1 is the maximum index. Keep that clear. The for loop has been enhanced to handle containers. Arrays are a type of container, so we can use the enhanced for loop to iterate over the values of the elements in the array. For example, summing is done by this example code. We assign the value 0 to sum, and we say for int score : scores. Read that as for score in scores, sum plus assigned score. The score variable of type int is a local variable that exists only for the duration of the for loop. It gets a copy of the element value as the for loop iterates over the elements. We'll start with the first element, that is index 0, move on to the second element, index 1, copy that value into the variable called score, and the body of my for loop takes that copy and adds it to the variable called sum. Score is a local variable that gets a copy of the element. If I were to modify score in the for loop, only the local variable would change. The actual element of the array would not change. This is called read only. The enhanced for loop is safe. You cannot inadvertently modify the value of the elements. If your code needs to modify the value of the elements, you must use the normal for loop structure where you have the 3 sections and compute the index value and then modify the element at those particular indexes.